Radiation dose is a measure of how much radiation we have been exposed to. So the dose is determined by the intensity of radiation and also the exposure. And dose is measured in sieverts, or SV. But you don't need to know what one sievert represents for your exams, just that it's a unit. Looking at some examples, we receive a small radiation dose from eating a banana, for example, about 0.0001 millisieverts, and this is a very small dose, so it's low risk. We receive a medium radiation dose from having an X-ray, about 0.1 millisieverts, so we need to limit the number of procedures that we have. A high dose is received when working in a nuclear power plant, so the people that work there limit their time working so they don't receive more than 50 millisieverts in 1 year. And 1000 millisieverts is equal to 1 sievert. But you don't need to remember these examples for your exams. So what risks are there from low doses of radiation? Well, low doses will not harm cells, but they can increase the risk of cancer. So healthy cells are not damaged when they're exposed to low doses. However, there is an increased risk of cancer, as the DNA has been affected by ionization. But this risk is quite low. So what about higher doses of radiation? Medium doses can kill cells, but the damage will not be fatal. However, the risk of cancer greatly increases. So cells will be killed, but they can be replaced and they will recover. But it will make a person very ill. And there is an increased risk of cancer as there's much more ionization. We observed increased numbers of cancer patients from survivors of disasters such as Chernobyl, Fukushima, Hiroshima and Nagasaki. So what about even higher doses? Well, large doses are very likely to be fatal. Around 30 people received this level of dose during the Chernobyl disaster. And this will damage the gut and bone marrow to the point where the body cannot function properly. So within organs and bones, the cells are killed, and the body cannot function without them, so they are damaged beyond repair. So how should we avoid receiving high doses of radiation? Well, we need to keep track of the radiation dose we receive to ensure that we do not suffer long-term damage. This table presents the size and the consequence of each dose. A low dose is less than 10 millisieverts, and with a low dose there's a slight increase to the risk of cancer. A medium dose is between 10 and 1000 millisieverts, and there's short-term cell damage and a higher risk of cancer. With a high dose, between 1 and 4 sieverts, fatal damage is likely, and with a very high dose, greater than 10 sieverts, fatal damage is guaranteed. So we want to keep the radiation dose we receive in the low level. You don't need to memorise these ranges, but you should be able to describe the effects of a dose size that's given to you either qualitatively or quantitatively, but it won't be ambiguous which range it would fall in.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!